Hello, this is Rick from MathX, and today we'll be doing number 27 from the 5th-6th Math Kangaroo of 2018. Now, this is another problem on our list of final problems of Math Kangaroo that are pretty easy to solve. And even though this problem looks quite intimidating at first glance, with 2x2 squares and 5x5 tables and 3 equal numbers, if we take a look to actually try to solve this problem, we realize that this problem is probably easier than some of the 4-pointers on the test, showing how Math Kangaroo doesn't list its problems from easiest to hardest. Anyways, without further talk, let's just go straight into the problem so you can see what I'm talking about. Write 0 or 1 in each cell of a 5x5 table, such that each 2x2 square of the 5x5 table contains exactly 3 equal numbers. What is the largest possible sum of the numbers in the table? So in the problem, it gives us certain information. It tells us that we can only write 0 or 1 in each of the cells. Each of the 2x2 cells has to contain exactly 3 equal numbers. And it's asking for what is the largest possible sum of all the numbers in the table. So the first thing we should do is take a look at each of these 2x2 squares with 3 equal numbers. So I'll just draw a 2x2 square and then we can analyze it. So here we have an example of any arbitrary 2x2 square. And in the problem, it tells us that this must contain 3 equal numbers. So that would mean that 3 of the numbers are the same, with 1 number being different. Now in the problem, it's also asking us to find the largest possible sum. So if we want to have the maximum possible sum, we should have 1 be 3 of the numbers and 0 be 1 of the numbers. Like this. Because if it was the other way, we would have a smaller sum. 3 zeros and 1 1, then the sum of all the numbers in the 4 squares would be 1, while in this way, the sum is 3. So we see that this is the maximum arrangement of putting 3 equal numbers and 1 different number in a 2x2 cell. But the problem doesn't give us zeros and ones in terms of a 2x2 cell. It gives us zeros and ones in terms of a 5x5 table. So that means we need to find a way to minimize the number of zeros and maximize the number of ones in this 5x5 table. Well, if we want to minimize the number of zeros and maximize the number of ones, we have to use as little zeros as possible. So that means in multiple 2x2 squares, we got to share the zeros. So let's take a look. In any square, the maximum number of 2x2 squares that can share that said square is 4. On this square, we see that there's 1, 2, 3, and 4. So that means if we put a 0 here, it would be used in 4 2x2 squares. Now that's the maximum number of 2x2 squares, because we see that if we put a 0 here, it's only going to be used in 2. And if we put it in the corner, it's only going to be used by 1. So in order to use the least zeros and use the least zeros in the most squares, we have to put a 0 in a location like this. Now, since this 5x5 table is symmetrical on all sides, we see that putting 1 here is like the same thing as putting 1 here, and putting 1 here, and putting 1 here. So by putting the zeros in these spots, we're minimizing the number of zeros we use while maximizing the number of 2x2 squares that get the 0. Now, since we placed down all the zeros and we ensured that each 2x2 square gets a 0, we can just place down ones in the remaining squares. And we see that this will give us the largest possible sum of the numbers in the table. So just to review what we've done was we've determined the maximum possible sum in each 2 by 2 square to be if there were 3 ones and 1 0. And then we figured out the way to minimize the number of zeros while maximizing the number of squares that receive said zeros. And then once we did that, we just wrote down the remaining numbers as ones. So now the final step in this problem is to sum up all the ones in this 5 by 5 table. We could just add them out, but there's a far easier trick to see here. Almost each of the cells in the 5 by 5 table has a 1. So let's say all of the cells in the 5 by 5 table had a 1. Then the sum of the ones would be 5 times 5 times 1. However, since 4 of them do not have 1s, we have to subtract 4 times 1. Doing so, we get 25 minus 4, or 21, as our answer, B. And we did this quick counting by just realizing all but 4 have 1s. So as you can see, we've just solved number 27 on the 5th, 6th grade Math Kangaroo of 2018. This problem is a 5-pointer and should be one of the most challenging problems on the test. However, we solved it with relative ease. In fact, some of the 4-pointers may be more difficult than this problem, showing that even though this problem is highly ranked on the test, it's not really that difficult, and that you shouldn't just go on the problems based off their problem numbers. You should actually take a look at the problem. Because by attempting as many problems as you can, you're going to maximize the number of points you get on the test. Don't hesitate to read over a problem, as who knows, even though that problem may be higher ranked than you're used to, by doing it, you can net yourself points you wouldn't have otherwise got. Showing on Math Kangaroo, in order to maximize the number of points you get, just try as many problems as you do, and don't necessarily go in order.